So today is still the 28th. So what I would like to do today is do more problems from 3.5, word problems, because we didn't get the chance to. And also a couple of problems from 3.6. And review for the rest of the time. Yes, I'm ready.
Okay, so the problem that I had, because I was just trying to figure
Yes.
out the max and min, is,
Yes.
it's negative 2x to the fourth plus 2x to the third.
Very good. Okay, so let's do the whole thing. This is a good review, because I was going to review a polynomial function like that anyway. So thank you for picking the problem. Good. So we're asked to determine everything, and that everything will be mentioned to you, will be listed. So when I say everything, I mean domain, x and y intercepts, multiplicities, and behavior, y intercept, the maximum number of turns, degree, max min, just everything, right? And that will be listed for you. Like in the homework, yes. Yes. Problems will be selected from your homework, like I did last time.
So it's going to be a non-less plus 10. Is it going to be 20? It's going to be 25 questions. That's kind of long. I mean, it was. I mean, I think everyone agrees that it was long. Yeah, it was.
Are you
Could
gonna stay
we
3 hours
make it like
after?
22? 22? I think that's a nice number.
22.
I also did feel the love of your interactive problems.
Okay, so we start with a domain for this function, like we start with any function. And the domain is, very nice lobbying, by the way.
Negative means
Absolutely, it's a polynomial function. I will not see asymptotes when you graph polynomial functions, correct? You're not going to do that to me, right?
right. That's not right.
Right. It's defined everywhere. And there is no asymptotes whatsoever. Good. Good. What do you think I'm going to do next? Right away? Factor our negative 2x cubed. We have to look at the function and understand what it says to us. So obviously I will have to factor out 2x cubed. And then in parentheses I have, very good, x minus 1 indeed. Perfect. So what is the degree of this polynomial?
4.
Maximum number of turns possible.
3.
Yes. Max possible turns 3. Very good.
And to do that, you always minus 1.
Yes. Yes. Very good. And now I need to determine how many solutions, how many x-intercepts will you give? 4 solutions, because the degree is 4. Okay, very good. So I expect 4 solutions. Please tell me those 4 solutions. Yes, x equals 1. Multiplicity. Very good. And? Yes, how many times? What does multiplicity 1 mean? Very good, awesome. And what does multiplicity 3 mean? Slow cross. Whatever you want to write, I'll accept it. Perfect. So I'll go back to the chart. I will put 0, 0. I will put 1, 0. I will write above x equals 1. I will write a cross, so I don't forget. And above 0, 0, I will say slow cross.
Why is it slow again?
I'm sorry?
Why is it slow? Oh, because it's
All
3
the
of them.
odd multiplicities are crosses.
And it's slow because it's 3 of them.
Exactly. Good. Leading coefficient.
Negative 2.
Good. Which means Does it do this or does it do this?
Second.
Second one, of course, which means the end behavior is
Negative.
very good. Perfect.
Wait, can you repeat that?
If the degree is even, it behaves like x squared. If the degree is odd, it behaves like x. And since the leading coefficient is negative, we know that negative x squared will look like this. Better? Okay. So now I'm trying to make sense of what I see. So here's what I see. From negative infinity, it comes to the origin. It takes its time. It finally crosses. It has to come to a maximum. In other words, a turn. Because it comes back to cross at 1, 0 and go into negative infinity. One more time. From negative infinity, comes to the origin very slowly, takes its time to cross at the origin, but it has to come to a maximum because it has to come back and cross at 1, 0 and go to negative infinity. So the graph will look like this. It crosses at 1, it crosses at 0. It's coming from negative infinity, it takes its time to cross, it comes to a maximum, and it goes to negative infinity, crossing at 1. So this is f of x equals negative 2x to the 4th plus 2x cubed. And Missy, this is not the function you showed me. You picked another problem.
Oh, no, I think I forgot to put the negative. It's the same function, but I forgot to put the negative 2 instead of,
Oh.
yeah.
Good. So obviously, this function has an absolute maximum and a local maximum right here. And the range will be between negative infinity and that number. Yes, please, check. Yeah, the absolute means there is nothing above it. It's the absolute, the maximum possible. Local means that I can show the open interval. So the function can do this, and I have many max min. That is absolute because there is nothing above it. Okay, with the graphing calculator now, I'm checking to see if they. No, something. I would probably have to log out and then log back in. Okay, so in y equals, we had negative 2 x to the 4th, and then plus 2x cubed. Okay, so now I want to adjust the viewing window by my liking. So I know what's happening here. The entire action is between negative 5, 5, positive 5, 5, negative 5, 5, negative 5, 5. I don't think it goes above, and if it does, I can adjust it again. So I go to the window, and I shouldn't even go negative 5, 5. So let's say negative 4, 4 with a scale of 1. And minimum negative 2 to positive 5 with a scale of 1. So it's coming, crosses slowly, comes to a little maximum, tiny, crosses again at 1, 0, going to negative infinity. So in order to find this maximum, I'll go to second and calc. I choose maximum, which is number 4. I give the left bound as 0. I give the right bound as 1. And I press enter. I don't want to guess. No, I don't care for your guess. So the maximum is obtained at 0.75 approximately. And how high is that maximum? 0.21. The reason I adjusted the viewing window is because I want to make sure that I didn't make a mistake. I wanted to see this slow cross. I wanted to see the height, the maximum, the turn, and a regular cross at 1, 0. Any questions? Is this better?
Yes.
Very good. Is there anything else? Is there anything else? Okay, I would like to go back to some more problems and some more solving polynomial and rational inequalities. And then we can say that we wrapped it up. So I'm looking at, so let me ask this. Are we okay with graphing polynomials? Are we okay with graphing rational functions? Type 1, type 2, type 3.
Another type 3.
Yes, let's choose a type 3.
I don't mind to choose that one.
Okay, you want me to choose type 3? Okay. No, not you. We're done with you. Okay, well, you can choose. Page 4. No, you don't. Okay. See, I'm positive on you. Okay, so type 3, type 3, type 3, type 3. Ah, yes, problem 80 on 427. And we have f of x, which is x squared minus, oh no, it's type 1. I'm sorry, I have to choose another.
We can do type 1. Work our way up to type 3, right?
But I still want to work on some more problems today. So that's the review day. Okay, so I'm sorry I did not see the square when I copied initially. So this is type 1 because the degree of the top is
Same.
2 and then the degree of the bottom is 2. So it is type 1. Good. Very good. What is specific to type 1? Yes, but also a horizontal asymptote and vertical asymptotes, not slant. Which is the typical for which type? Type 3 is typical for slant. Type 1 and type 2 do not have slant asymptotes. They have vertical and horizontal. No function can have horizontal and slant at the same time. Very good. So what will I do first? Say it again. Yes, but I can simplify before I do what? Exactly. That's the key word. In this case, I cannot simplify by anything before I factor. Good. So I'm ready for the top.
X plus 1.
X minus 1. Minus 1.
X
Minus 3,
Minus
X plus 1.
Very good. X minus 3 times x minus 1 over. Did we do this problem before? I don't want to do the same problem. Did we do this one? Okay, never mind then. Good. So what is the next step after I factor and I see what's happening here? I need to identify the...
Don't you gotta factor the bottom?
How do we factor the denominator? Can anyone tell us how to factor a denominator?
X plus 1 plus X 1.
Yes, Shannon? No, it's already factored. I don't have anything to factor in the denominator. It's x plus 1 times x plus 1, but it's x plus 1 squared. There is nothing we can do to the bottom. It's already factored.
X squared plus 2x.
But that's not factored. You're right. It is x squared plus 2x plus 1, but I don't want that. Good. Okay, so then now the domain, please. The next step is the domain. What is the domain? It's a rational function. It's a rational function.
Negative things. To negative.
Correct. Very good. Then we know that rational functions are not friendly and we always have to worry about the denominator being 0. Do we remember that? Yes?
Yes.
Perfect. Good. So does x plus 1 go away with a factor from the top? No. So what does that mean? Very good. Once you say that, what will you write immediately? Exactly. And now I take my time to identify the sign of those infinities with a negative 1.1 and negative 0.9. I put them up there because they're not part of my chart. I will not plot something like that. So let's plug it in the first. Negative 1.1 minus 3. Awesome. In the second. In the bottom. Right, so I wouldn't even bother with this. Whatever I plug in, it will end up being squared. I don't worry about that. Good. So then two negatives. Perfect. Negative 0.9. Negative 0.9. I don't care about the bottom. It's always positive. So two negatives. Ah, it appears that this is the case of this. Not this. Not this. Not this. But this. Okay. Good. So now plug in 0, please. 0, 0, 3. 0 plus 1, 1 squared. Very good. Awesome. Thank you. Good. Now I want to find the x-intercepts. When is a ratio 0? When? Well, it will be undefined. I already know. When the numerator is 0. When is this numerator 0? 1 and very good. 1 and 3. Finally, I want the end behavior in the horizontal asymptote. How do I find the horizontal asymptote for type 1? Leading coefficient over the leading coefficient. What is the leading coefficient of the top? What is the leading coefficient for the bottom? What is 1 over 1? 1. So what is the horizontal asymptote? 1. Let's stop for a moment. Which part you did not remember so I can re-emphasize it, because this is important. Which one? You said all of it? I'm going to chase you around the block. Which part wasn't clear?
Yes.
It's type 1. Leading coefficient over leading coefficient. That's, it's the leading coefficient is 2 and the bottom coefficient is 1. It's 2 over 1, 2. Whatever it is. The leading coefficient for this is 1. The leading coefficient for this is 1. So 1 over 1 would be 1. Whatever you get. Top leading coefficient of the bottom leading coefficient for type 1.
So if it was negative 2x plus 2, it would be negative 2.
Negative 2x? No, it will be 0. Because if the leading coefficient here is negative 2 and the term is negative 2x, then this is type 1. Type 2, not type 1 anymore. If you meant square, then it's negative 2 over 1, which is negative 2. Yep. Yep. Very good. Other questions here? Is there anything else? Yes, Marcus?
Should we explain this? But like, you were finding the domain, and if negative 1, how did you get negative 1?
X plus 1 equals 0. I move 1 to the other side. I get x equals negative 1.
Oh, okay.
Okay? Perfect. I'm trying to make sense of the information. I don't know if I can, but I have to try. From approaching 1, above 1, it's going to positive infinity. That's easy. It's very clear. From approaching 1, that's negative infinity, going up to positive infinity on the left-hand side of the vertical asymptote. Now on this side, it's coming from positive infinity. It crosses the y-axis at 0, 3. it crosses the x-axis at 1, 0. Now it's below the x-axis. It has to come back. It has to have a turn. Because it has to come back and cross again at 3, 0, and eventually approach 1. Make sense? Let's try again. From above 1, going up to positive infinity. Easy. On this side, it's coming from positive infinity. It's crossing the y-axis at 0, 3. It comes down to the x-axis where it crosses at 1, 0. Because this is multiplicity 1, it has to cross. And it has to come back to 3, 0. So it has to have a turn, coming back and crossing again at 3, 0, and eventually approaching 1 from below 1. Does it make sense? I know I look silly doing all this over there, but I'm hoping that rings a bell or helps you understand the function. Ready? So let's put this in writing, what we just discussed. So when I graph a function with asymptotes, what do I have to graph first? How many asymptotes do I have to graph for this function type 1? 2, and they are? X equals -1 indeed, and y equals 1. I have to plot 0, 3. This is 0, 3. I have to plot 1, 0. And I have to plot 3, 0.
How do we get the 1 and 3?
A fraction is 0 when the top is 0. I have x minus 1 and x minus 3. When I set that equal to 0, I get x equals 1 and x equals 3. So a fraction is 0 when the top is 0. So 3 and 1. Better? Perfect. Always stop me if you have questions, please. Okay, so my chart says this. From approaching 1 above, go to positive infinity. Then it says from positive infinity, cross the y-axis, cross the x-axis, turn, cross the x-axis again, and make sure you approach the horizontal asymptote from below. A rational function can cross a vertical asymptote?
No.
Never. Can a rational function cross a horizontal asymptote?
Yes.
Yes, because we said what? That this has no meaning here. This has no meaning. You can even erase it from here if you don't want it. The meaning is here and here. So the function can cross a horizontal and can cross a slant. Okay. So obviously, I stretched a little bit here. It has to be smooth, continuous. So it's a little bit. So I'm gonna.
In the test, are you going to notice also?
Yes, I will. Yes. Just kidding. So this is important because obviously the function doesn't have a corner or something in there. So it should be more like this. Smooth, continuous function, except at -1, of course. This is more like it. I have no way of finding this minimum by hand. I have to find it with a graphing calculator. So we're ready. With the graphing calculator, I'm looking again. Oh, gee, wonderful. Sorry, just 1 second. Okay. With the graphing calculator, delete, clear. Okay, so I plug in x squared, parentheses, don't forget parentheses, x squared minus 4x and plus 3. Close the parenthesis and divide by x plus 1, parentheses, x plus 1, everything squared.
I forgot the plus sign between x and 3.
Thank you, thank you, thank you. I didn't, but it's just I didn't click properly. Thank you. Okay, what else do I have to put in the y equals, because the calculator will not graph it? Which is? Awesome. Yes, indeed. 1. I'm going to use a standard. Not really. I don't think that this is too low. I don't really need negative 10, 10. I'm going to say maybe negative 5 to positive 5, and negative 3 to positive 6. Because I need to see what's happening there. So the viewing window in window, negative 5 to positive 5, it's good enough. With a scale of 1, negative 2 to positive 5 is good enough too. I'm fine with that. What's happening here? Good. So the vertical asymptote is at negative 1. It's coming from positive 1, going, I don't care to see this side, it's very clear. It's coming from positive infinity, crossing at 0, 3, crossing at 1, 0, crossing at 3, 0, coming to a turn, and then eventually approaching 1. I need to determine this between 1 and 3. So second and calc, it's a minimum. So I want 3, and I wanted a calculator to find it between 1 and 3. 1, enter, 3, enter, no guess, enter again. And it is 1.67. 1.67 and negative 0.125. So yes, once you have the graph, you should come up with a better viewing window than. So the left bound is 1, the right bound is 3, and press enter for the guess.
How do we know what the top is?
Once I graph the function, I have a very good idea, right? So once I had this graph, right? I knew that this could not be too low. I did not really need to see this side because it was very clear to me. I didn't really need to see this side because it was very clear to me. I really didn't really need to see this, the top one, because all the action is basically here. And I wanted to see this. So you are only supposed to check with the graphing calculator and find the max min. I don't want you to rely on the graphing calculator. Because if you copy something that is totally off, then I know. I want you to understand the graph. Good. So this was type 1. Do we need now type 3? Okay, perfect. Sorry about that. Sorry for the wait. 80. Your bend. 87. F of x equals x to the third plus 1. I think we did this one. Yes or no, or it doesn't matter. It's up to you. Okay, perfect.
So, okay, so for the last one,
Yes.
we graphed like on the graph calculator, the bottom part is not the same as we graphed it. It's impossible. Like you see, like here, down lower, and here.
Right, but you can change the viewing window. Let's say we want to go to -2, you want to go to -1 if you want, and +2. You'll see even better. It's the exact same graph. It has to be.
See, on the other view, it looks closer to the.
That's why we should not trust the calculator. We should graph it carefully, step by step, how we understand it and what we read from the chart, and then only check with the graph. Because the calculator can lie. Very good point. So if we don't choose the correct viewing window, it shall be asked. If you don't choose the correct viewing window, you will see even that this is part of the x-axis, and that would be a terrible mistake. We know it's not possible. It only has 2 x-intercepts. You cannot sit on the x-axis 15 times. It crosses at 1, it has to turn, it crosses at 3. Nothing in between. Good. Okay, what type is this? Yes, it is type 3. What we did. Okay, so let's choose another. Thank you. Did we do 86 or 88? Okay, so let's look at 86. F of x equals x squared minus x plus 1 divided by x minus 1. Very good. What type is this? Yes, because the degree of the top is exactly 1 more than the bottom, or if you want to say the bottom is exactly 1 less than the top. What happens when when we encounter that situation? Exactly, because the quotient will be degree 1. When I divide degree 2 by degree 1, I get degree 1. Every time I think of a function degree 1, how does it look? Not this. So this function cannot have a horizontal asymptote. It will have a slant asymptote, which can be this with a positive slope, or it can be this with a negative slope. The function must follow the asymptote. Like it followed the horizontal one, it must follow the slant one. That's the key. Okay, perfect. So we start with a chart. Now, you can say you're changing the rules. On all these previous problems, you factored the top. Now I'm going to ask you, can I factor the top? The answer is no. It's not factorable. That's why I didn't say anything about it. Good. What is the domain of this function?
All real numbers.
Why would you say, hold on, why would you say all real numbers?
Domain is
But can a rational function be defined on real numbers before I check something? No. What do I have to check?
well,
Except when the denominator is 0. Can this denominator be 0? If you say this denominator can never be 0, then I will have to accept negative infinity to infinity.
Can I say it? Right?
No, you will be wrong. But if the denominator is x squared plus 1, then I will accept all real numbers. Why would I accept all real numbers if the denominator were x squared plus 1? How come?
It's a
This would always be at least 1 or 2.
Because x squared plus 1 is never 0. Is a positive number plus another positive number. Positive plus positive, can that be 0? So for this, whatever you want at the top, if the denominator is x squared plus 1, then I would have to accept all real numbers. But here I cannot accept all real numbers. Because if I ask you plug in 1 in it and give me the outcome, it will say, I can't. Because 1 will make the denominator 0 and the whole thing undefined. Is that clear? So if the function is rational, we always have to look at the denominator before we decide the domain. Okay. Good. So you already told me negative infinity to 1. Since the numerator is not factorable, can I get rid of the factor x minus 1 in the denominator? Because if I can't get rid of the factor in the denominator, then x equals 1 would be? Exactly. If I cannot get rid of this factor, then x equals 1 will be Good. Which one is it? I have to write something about x equals 1 and make a decision. But can I remove the x minus 1 with the top factor of x minus 1? If I can, but this is not factorable. If it's not factorable, x minus 1 is not, right? If you plug in 1, you get 1 minus 1 plus 1. So the remainder is not 0 by the remainder theorem, right? So then x equals 1 is very good, which will immediately make us determine the signs of those infinities. So I plug in 0.9.
You always have to plug in like
Numbers as close as possible to that.
so you can,
Because there may be a max or a min in between, and then I mess up the whole thing. Yes. I will not plot those ordered pairs, but I have to use a number very close, left and right. And 1.1. Okay. So 0.9 squared minus 0.9 and plus 1. It's all positive, bless you. And 0.9 minus 1. Very good, awesome. With 1.1, positive and negative in the denominator. Very good, awesome. We will catch the mistake if there is one very easily. When we finish filling up the chart, if it has to go all over the place and it makes no sense, then I know I have a mistake. Okay? So, let's plug in 0. This is never 0, we can try. So a fraction is 0 when the top is 0. So if you try x squared minus x plus 1 to set it equal to 0, you will use the quadratic formula. Negative b plus or minus b squared minus 4ac over 2, not real. So there are no x-intercepts. What do I have to do last? No x-intercepts, I found the y-intercept, I found the behavior near the vertical asymptote. I know it's not symmetric. If it has a vertical asymptote at 1 and it doesn't have a negative 1, it cannot be symmetric. I'm going to write that too. But what is the last thing I need? Exactly, to fill up my chart. I don't have this. Since I don't have this, I know I have to determine either horizontal or slant. Since it's type 3, I cannot find a horizontal. There is none. So what will I have to do to find the slant? Say it again. Exactly. Since I'm lucky with x minus 1, I can use either synthetic or long division, whatever you want. Okay, what goes in the box? Coefficients for x squared minus x plus 1. Good. I bring down 1. 1 times 1. 0. 1 times 0. And I box in what? Very good. Perfect. What is the degree of this quotient? Plus 0. Yes, it has to be degree 1, so it's x plus 0, which is just x. Very good. Any questions?
So your
Slant.
I'm sorry, your slant asymptote is x.
Yes. So y equals x slant asymptote. So now I have to find the end behavior. Does y equals x look like this? If you say yes, then I'm going to write negative infinity to positive infinity. If y equals x looks like this, then I will write positive infinity to negative infinity. I agree. So it's negative infinity to positive infinity. I'm trying to make sense of this information. Let's see if we can. From approaching the slant asymptote, it's coming up and crossing the y-axis at 0, -1, and then it drops down to -infinity on the left-hand side of the vertical asymptote. Okay, so it looks like this. Crossing the y-axis and going to -infinity on the left-hand side of 1. Okay. On the other side of 1, it's coming from positive infinity. You cannot connect infinity. It has to come down to a minimum, like x squared does, and approach the slant asymptote. It makes sense. So let's give it a shot. I took my chart away. I can't do anything without it. Okay. When I graph a function with asymptotes, what do I have to graph first? How many asymptotes does this function have? 2. So the first one is? I don't know how to plot 1. Thank you. Indeed, x equals 1. And the other asymptote is? I know how to graph this. When x is 1, y is 1. When x is 0, y is 0. When x is 2, y is 2. Good. I'm looking at my chart now. Ready? 0, -1 is this point. From approaching -infinity, coming to cross the x-axis. I don't know if it turns here. I have no idea. It can go all the way more and then continue. You can even turn here, or you can turn on this side and go down. I don't know. That I have no way of determining that without the graphing calculator. It can turn before it crosses the x-axis. It can turn unlikely, I would say, on the x-axis, or it can go ahead and continue. I think that this is stretching it, but it's possible. I think the maximum will be before it crosses, but that's why we have the calculator for it. On the other side, very clear, from positive infinity going to positive infinity. I have to determine this maximum in this area and this minimum in this area. And this is the graph of f of x, x squared minus x plus 1 over x minus 1. Ready?